So today we're going to start 5-5 and we'll finish it tomorrow. So today we're only going to cover the shortcut that's called SSS, which stands for the side-side-side congruence theorem. So what the side-side-side congruence theorem states is that if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Go through and we're going to match. So if they ask you to show all of the congruent corresponding parts, this is what you would have to state. So first I'm going to go through here and show that AB, the one with the single tick mark, is congruent to DE. So I can say that AB is congruent to DE. And then I can also state that BC is congruent to EF. And then lastly, I can say that AC is congruent to DF. Now, if they also ask you to write a congruency statement, the order that you write the letters is important. So my congruency statement, I could start out by putting the first one in alphabetical order. I could say that ABC is congruent. Now, when I write the order of the letters for the second triangle, it has to be in the perfect match. So D, E, F, and notice what you could do is look back on how you wrote your statements. Notice how AB is matching with DE. AB are my first two letters, and I'm matching them over here with the same first two letters. And then by default, that third angle C and the third angle F would also go in there. So if they ask you to write a congruent, all the corresponding parts using side, 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 this is what you would do. You'd come up with three congruency statements showing all three sides are congruent. And then from there, write your congruency statement. Everything needs to match. Try an application. We need to decide if the statement that they gave us, that triangle DFG is congruent to HJK, if this is true or false. So I'm going to go back through and I'm going to make sure everything matches in the correct order. So notice over here I have my single tick mark or single congruency mark. So I could state that DG is congruent to HK. Then I'm going to come over here and get the one that has two congruency marks. And I can state that DF is congruent to HJ. And then lastly, I could also say the one with three congruency marks is congruent to the other one with three marks. So I could say that FG is congruent to JK. Now, to double check that it's in the correct order, I can go back and look at my sides. So notice here in the blue one, notice how I have DF and it's matching here with HJ. DF is the first two letters and it's matching here with the first two letters. And then if you wanted to double check the last two, see how FG is the last two and it matches with JK. So their statement is good. This is true. Pretty good? Yes. Yes. All right, let's try the next one. Again, same thing. Let's go through and match. This time, instead of congruency marks, they've got numbers on the sides. So let's see if what they stated was true. So I could go back through and say, okay, I'm going to look at AC and CA. Well, AC and CA, that's this same middle side. So we could say, yes, this is true that AC equals itself because 9 equals 9. Then let's go and look at the next one. I could say CB with AD. So CB, let's see if it's congruent to AD. So CB is 7 and AD is 7. So that's working out so far. So far so good. But now when I try the first and the last, the AB, and see if it matches with CD. AB is 3, CD is 4. These are not congruent sides, so this statement is false. In order to prove them congruent, all 3 sides would have needed to match up and have congruencies. The only way they would have been congruent is either this would have had to have been a 3 or this would have had to have been a 4. Everything else matched. Another example. Same thing. Let's see if their statement is true. So let's go through and see if everything matches. Let's match QP. So the first 2 letters, first 2 letters with the first 2 letters here. So QP is here, and it wants us to match it with RS. They both have 2 congruence marks, so that works. QP is congruent to RS. Let's go and take the last 2, the PT and the ST. Well, PT is here with 3 and ST's with 3. So far, so good. So let's do it in the order. PT is congruent to ST. And then lastly, let's go beginning to end. QT and RT. And yes, indeed, they have the same marks. So I would say this is true. This statement is correct. Everything had congruency marks. So here we have a real life problem. So it wants us to explain why the bench with the diagonal support is stable while the one without the support could collapse. So we're going to be using our side-side-side theorem to explain why it's more stable. So notice that the diagonal support, we are creating 2 congruent triangles here. Let's see if I can. Maybe I have this black one here, and then I've got this one here. So because these are congruent triangles and all the sides are the same, this would be a fixed quadrilateral. It can't shift, it can't change. So because it can't change shape, and it's going to stay the same quadrilateral shape, it's going to stay the same quadrilateral with the same given side lengths. So because these 2 triangles are side, 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 and the lengths of all the sides stay the same, that's why this one is more stable. This one could shift. It could sort of tilt and maybe turn into a parallelogram and wobble back and forth. And the side lengths could change. Maybe the top would shift. So this is why this one would not be more stable. All right. So before we can even think about identifying what the hypotenuse leg congruence theorem is, we need to know the parts of a right triangle. Now, all of these shortcuts are only requiring us to find 3 things. Now, in the shortcut that we're about to see, it's called HL. And the H represents the hypotenuse, and the L represents the leg. All the other shortcuts that we're going to learn are going to have 3 letters. For example, we learned side, angle, side. We just learned side, side, side. And you look at this and you think, well, why does it only have 2? It only applies to right triangles. So the first thing you need to do before you can try to use hypotenuse leg is make sure your triangle is right. So the first thing you're looking for is a right angle, and then you're looking to see if the hypotenuse and one of the legs is marked as congruent. So the hypotenuse is always going to be the side that's across from the right angle. The legs of a right triangle are going to be the sides that form the right angle. So these are the parts of a right triangle. The 2 sides that make the right angle, that come together and form the little box, those are the legs, and then the side across from it is called the hypotenuse. So let's just go ahead and take a look at the theorem, and then we'll stop here. So this is the official hypotenuse leg theorem, and it states that if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the 2 triangles are congruent. So what we would be looking for are 2 right triangles. It needs to have the right angle. That's the first thing you look for. And then you would look for a congruency mark on the hypotenuse, and then a congruency mark on one of the legs. So if they ask us to write a statement here, let's see, A, B, C, and then if I call this can call this DEF. Now let's go through and state what we need to in order to prove this with hypotenuse leg. The first thing we would need to state is that angle B equals, or the measure of angle B equals the measure of angle E, which equals 90 degrees. First, establish that you have a right triangle. Next, we're going to show congruencies on the hypotenuse and on one of the legs. So then you would also state that AC is congruent to DF, and that BC is congruent to EF. This is the hypotenuse, this is a leg, and then this is indicating it's a right triangle. So because I've shown the hypotenuses are congruent, one of the leg pairs, and that I have a right angle, I could state that triangle ABC is congruent to triangle DEF by hypotenuse leg. Okay, so let's go ahead and continue on. So this one is giving us coordinates for JKL and RST. So the first thing I'm going to do is graph them in the same coordinate plane, and I'm going to show that they're congruent. And in this one, I'm going to show that they're congruent by either side, 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 or hypotenuse leg. So let me go ahead and graph JKL. So I'm going to graph JKL in red. So I'm going to graph order pair J. So it's -3, -2. This one's J. Then I'm going to graph K, which is 0, negative 2. And then I'm going to graph L, which is negative 3, negative 8. So it's going to be way down here. It's going to be off the graph. So we'll put it here. So we'll go ahead and connect the points and make my triangle. Now, what's nice here is I could count the squares for the horizontal and the vertical side. So this has a length of 3. And then this one, 1, 2, 3, 4, 5, 6. This one has a length of 6. So this would be 7 here, and then 8. So now, however, for the length of LK, I need to use the distance formula. I can't just count the squares. Now, I could have also done the distance formula to find the length of JK and JL, but again, since it's graphed, I can just count the units. So let's go ahead and find the length of LK. So again, remember the order pair 2. So K is 0, 2, and L is negative 3, negative 8. So let's go ahead and do the distance formula. I'm going to subtract the x's, negative 3 minus 0 squared, plus negative 8 minus negative 2 squared, all under the square root, negative 3 squared, plus negative 8 plus 2. This is really negative 8 plus 2. So this is negative 6 squared. So 9 plus 36. And I get the square root of 45. Now, in simplest radical form, I could break the 45 into 9 times 5. So 3 square root 5. That's going to be the length of LK. Now let me go ahead and graph the other triangle, RST. And I could do that one in blue. Let me go ahead and graph those order pairs. So R is 10, 0. That's R. And then T is 4, 0. And then S is 10, negative 3. So I'll come over here, put my point, connect my points, create my triangle. So this has a length of 3. I can count the little units. This one is 1, 2, 3, 4, 5, 6. And again, now I need to do the distance formula and find the length of ST. So again, I'm going to subtract the 2 coordinates. So I can do my x's, 10 minus 4 squared, plus negative 3 minus 0 squared. 10 minus 4 is 6. Negative 3 minus 0 is negative 3. Square. Add. I still get 45. So this again simplifies to 3 square root 5. So because all 3 sides are congruent, then I could say, yes, they are congruent triangles. And I could actually write a congruency statement. I could say that triangle JKL, and J to K is the 3, is congruent to RST. So let's see, actually, so is congruent to triangle RST. So from R, is it this order? Let me look at this. So let's go in the correct order. So I'm going from the right angle mark here, from J to K, across the hypotenuse to L. So here I'm going to go from S to R. Let's see, no, I'm going to go over here. So I'm going to go from R to S to T. And that would be your congruency statement. Make sure everything matches. Notice the J and the R are both the right angle. And then the K is here at the end of the 3, which matches with the S, and then to the T. So these are congruent. And the congruent reason would be side, 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 because all three sides are congruent. Let's take a look at the next example. Is there enough information to prove that these two triangles are congruent? If so, state the theorem or postulate. So the first thing I'm going to notice here is I have right angles. So because I've got some right triangles going on, now I'm going to go back and I'm going to look to see if there is enough information. And notice I have a leg, and then I have the hypotenuse marked. So yes, there is enough information, and I can prove that these two triangles are congruent by hypotenuse leg. Now let's quick do a proof using hypotenuse leg. Let me go ahead, and first thing I did was I pulled the two triangles apart so I could clearly see which ones they were asking me to prove are congruent. So they're asking me to prove that WYZ, which is here, this bottom one, is congruent to this one, and they're overlapping. So sometimes it helps you to pull them apart and face them in the same orientation. So over here, I've already added all of my given. Because they told me that WZ was perpendicular to ZY, I knew that this formed a right angle. Same thing here, XY perpendicular to ZY, then this is also a right angle. Then they also gave me that WY was congruent to XZ, so that's why this has the two markings here. So let's go ahead and get your given put into the proof. So WY congruent to XZ, and WZ is perpendicular to ZY, and XY perpendicular to ZY. All of this was given to us. Now let's go back and see what else we can get in here to prove that these two triangles are congruent. So just by my stating that these are perpendicular, I also have to establish that angle Z, and because I pulled them apart, I can name it with just one letter. However, if I would have left it in there, then I would name it with 3. So I'm going to establish that angle Z and angle Y are right angles. And this is definition of perpendicular lines. Okay, if I were leaving it in the picture, angle Z is the same thing as angle WZY, and angle Y would be angle XYZ, or you could reverse the order of the letters. Next thing I have to establish is that triangle WYZ and triangle XZY are right triangles. And then this is by definition of a right triangle. Next, I need to get in here. So far I've got a right angle marked. I've got the hypotenuse marked. Now I just need to establish that the leg is congruent. And if you notice that right here, this side ZY is the same on both of these. So all I have to say is that ZY is congruent to YZ, and this is the reflexive property. And then now I can say what I was trying to prove, that triangle WYZ is congruent to triangle XZY, and my reason is the hypotenuse leg congruence theorem. When you're writing this yourself, you can just put HL. That's enough information. So that concludes the notes on 2 more shortcuts, side, 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 and hypotenuse leg.